Alright guys, so chapter 4, trig. Alright, so the first one is, given that theta is 54 pi over 5, find its reference angle and one coterminal angle such that the coterminal angle is between 0 and 2 pi. Alright, so I probably got to draw this so I can figure out where it's going to be. Alright, so since I'm doing pi over 5, I know that 2 pi is 20 pi over 5. Not 15, sorry. And then, nope, sorry, I'm screwing up here. It's 10 pi over 5. And pi is 5 pi over 5. Alright, and then this is going to be half. And then that's half in there. Alright, so just so I know where my axis angles are, gives me an idea of where I should go. Alright, so 54 pi over 5. So if I go around 1 time, that's 10, 2 times is 20, 3 times is 30, 4 times is 40, 5 times is 50, right? So that leaves me with 4 pi over 5 left. So where would 4 pi over 5 go? Which that would be right over here. All right, so that is so because I figured out, you know, how many full rotations I have, right? So I have 5 full rotations, which gives me 50 pi over 5, right? That means I still have 4 pi over 5 left, right? So that is my coterminal angle there. All right, and then you want to, for your reference angle, how far away is 4 pi over 5 away from 5 pi over 5, which is 1 pi over 5. All right, so I think if you guys draw it out, it's probably the easiest way to come up with the answer for that one. Next one is the same thing. So negative 127 pi over 12. All right, so I know that 2 pi is 24 pi over 12. 1 pi, 12. Pi over 2. And 3 pi over 2. All right, so how close am I going to get? So all right, if I go around 1 timer, right, that's 24. Again would be 48. Again would be 72. Again would be 96. So 4 full rotations is 96 pi over 12. Or negative 96 pi over 12 if we're going the opposite direction. And then what does that leave me with left? That's, if I do it again, that's 120 pi. Okay, so that leaves me with negative 7 pi over 12 left. Okay, so where would that go? All right, so since we're doing negatives, let's see if let's actually change these. That's negative 18 pi over 12, negative 6 pi over 12. Okay, so 1, 2, 3, 4. So 5 rotations is negative 120 pi over 12. So I have negative 7 pi over 12 left, right? Which should put me about here, right? So this would be negative 7 pi over 12. All right. Now my reference angle, again, is how far away I'm from the x-axis. So how far away is -7 from -12? So your reference angle is 5 pi over 12. Remember, reference angles are always positive, regardless of the angle that you're working with. And then the coterminal angle, remember, it's got to be between 0 and 2 pi. So if I add 2 pi to that, right, 24 pi over 12 plus -7 pi over 12 is going to be 17 pi over 12. So those are my two answers there. All right, next one, you're just using evaluating the trig functions. So sine of 5 pi over 6, positive y, so that is positive 1/2. Secant of 11 pi over 6. All right, so 11 pi over 6 is 3 pi, root 3 over 2, and -1/2. So secant is the reciprocal of the x term. So that's 2 over root 3, which is then 2 root 3 over 3. Tangent of 5 pi over 2. So that's the same thing as tangent of pi over 2. All right, which again is going to be -1 over 0, which, or positive 1, sorry, positive 1 over 0. So that does not exist. All right, cotangent, -7 pi over 6. All right, so -7 pi over 6 is the same thing as 5 pi over 6. All right, so the coordinate there is -√3 over 2 and 1/2. All right, so cotangent is x over y. So -√3 over 2 divided by 1/2, which simplifies to be -√3. Cosecant of 13 pi over 3. So cosecant 13 pi over 3 is the same thing as 1 pi over 3, right? Coterminal angle. And then pi over 3 is 1/2 and root 3 over 2, right? And cosecant is the reciprocal of the y term. So 2 over root 3, which 2 over root 3. Tangent of pi over 6. So root 3 over 2, comma 1/2. So that's 1/2 divided by root 3 over 2, which comes out to be 1 over root 3, which is then root 3 over 3. Secant -5 pi over 3 is the same thing as secant of pi over 3, which is 1/2 root 3 over 2. Secant, the reciprocal of the x term, so 1 over 1/2 is 2. And then the last one here, cotangent of 11 pi over 4. So 11 pi over 4 is the coterminal with 3 pi over 4. And that's -√2 over 2, root 2 over 2. So x over y here is going to give me -1. Okay, so moving on to the next one, says cosine is -1/4 and tangent is positive. Find the remaining values of the other trig functions. All right, so if cosine's negative, right, So that puts me either in quadrant 2 or 3, and tangent's positive, right? We know tangent is y over x. So if I already know that x is negative, right, because I know that x is -1 and r would be 4, right? If I already know that x is negative, that means that y must be negative as well. So that tells me that I need to go in quadrant 3. So that's -1, that's 4. And then the missing value would be root 15, negative root 15. And you guys can do Pythagorean to figure that out. So sine of theta is going to be negative root 15 over 4. Cosecant of theta is going to be negative 4 over root 15, which is negative 4 root 15 over 15. Cosine, we already know is negative 1/4, which then secant is negative 4. And then tangent is negative root 15. Over -1, which is just root 15. And then cotangent is -1 over negative root 15, which is root 15 over 15. All right, so those are your 6 values there. All right, so 70 says determine the shift for h of theta. All right, so I'm going to take out a 3. All right, so 2 pi over 3 divided by 3 is 2 pi over 6, which is why am I blanking? 2 pi over 6. No. That's 2 pi over 9. Yeah, 2 pi over 3 divided by 3 is 2 pi over 9. So this one is going to move right 2 pi over 9. All right, 71, maximum value. Okay, so I know that my period, not my period, my amplitude is 2, and my axis is at 7, right? So I'm going to go 2 above and 2 below my axis, right? So my range is going to go from 5 to 9. So my maximum value is going to be positive 9. The graph of cosine will coincide with the graph of the sine function if the cosine graph is moved how many radians to the right. All right, so graph of cosine looks like that. And then the graph of sine looks like that, right? So I need to figure out how many radians to the right do I need to move my graph in order for them to overlap each other, right? So if you guys know your values, right, we know that this is 0. Here's pi over 2. Here is pi. 3 pi over 2. And here is 2 pi, right? So if I take this point here and I move it over, okay, I have to move it over pi over 2, and then everything should line up, right? So then the blue is going to overlap with the red. Now there's also an identity. They're called cofunction identities. It's pretty much called like sine of theta equals cosine of pi over 2 minus theta. Oops, sorry, let me put that there. We didn't really talk about them, and that's all right, as long as you guys know what the graph looks like. But that's kind of also where the pi over 2 comes from. It comes from those cofunction identities. So it's just a shift pi over 2 to the right. All right, write an equation with the following information. Okay, so the amplitude is 3. The period is pi over 2, which then makes the b value 4. Phase shift is negative. Oops, sorry. We're going to move left pi over 4. And then the shift up is 9, right? And we're writing a sine function. So this is going to be y equals my amplitude times the b value, and then the shift. So we're doing x plus pi over 4, and then plus 9. Oh, sorry. What did we say the b value was? B value was 4, so 4 needs to go here. Sorry. Yeah, so as long as you guys put it in the standard form, you should be pretty good. You don't really need to multiply it out. It's kind of like unnecessary work there. 74, write 2 equations that represent the graph, one in terms of sine, and then the other in terms of cosine. Okay, so where is my axis? So my axis is in the middle here. All right, it looks like, so D is 3. My amplitude is 2, right, because I'm going 2 above, 2 below. Now, what is my period? So if I start at 0 and I finish at 8, right, my period equals 8, right? So that makes my b value pi over 4, okay? Now remember, if you're starting on an axis value, it's sine. You're going to start on a higher low point, that's cosine. So the first one I'm going to do is right here at x equals 0. So that's going to be y equals 2 sine pi over 4 x plus 3. And then the other one is going to be here at this high point, which is cosine. So y equals 2 cosine pi over 4 x minus 2 plus 3. All right, 75 says 2 consecutive maximum values at negative pi over 3 and pi over 6. And then the maximum values of the function is 9, and the minimum value is 3. Find an equation that represents the scenario in terms of both sine and cosine. Okay, so it says 2 maximum values are at those x values, right? So this here is going to help me figure out my period. Okay, so what is the period, right? So you're going to do pi over 6 minus negative pi over 3 Alright, so the period is pi over 2, which then makes the value for B 4. Alright. Okay, so it says the maximum value is 9 and the minimum value is 3, right? So my axis is going to be in the middle of that, right? So you take your highest point and your lowest point and take the average of them. That's going to give you your axis, right? So if 6 is my axis, the distance from the highest and the lowest point from the axis is going to be 3. So the amplitude equals 3, right? Okay, so even if you guys wanted to graph this one, it might help. So we're starting at negative pi over 3, and we're going to start at 9. All right, now your period we said was pi over 2, right? So pi over 2 divided by 4 is pi over 8. So negative pi over 3 plus pi over 8 . I'm just trying to figure out my interval here so I can kind of graph one of the graph the cosine curve here. So if I add another pi over 8, that's going to give me negative 2 pi over 24, which is negative pi over 12, which will go here. And then if I add another one, so what is that? That's pi over 24. And then if I add another 3 pi over 24, that's 4 pi over 24, which is pi over 6. Okay, so now my cosine, I got y equals my amplitude, which is 3, cosine, my b term, which is 4, and then it's x plus pi over 3 plus 6. and then cosine or sine is going to be -3 sine 4 x plus 5 pi over 24 plus 6. All right, so I know this one kind of takes a little bit of time, but again, if you guys just take out all the information, you know, follow the same steps that we've been doing when we were graphing, you know, you can come up with the interval. I know it's not very, you know, nice like the other ones that we've been doing, but it's not impossible. You just got to take your time. Okay, so the next 6 are graphing. All right, so first one, amplitude is 3, b value is 2, which then makes the period. So 2 pi over 2, which is pi, which then is your interval, pi over 4, and then the axis is at -4. All right, so I'm going to draw my axis first. So you only need to graph one cycle for each of these. So I'm going to go all the way up to -1, and I'm going to go down to -7. Okay, so my period is pi, and I have to go up by pi over 4. So pi over 4, pi over 2, 3 pi over 4, and pi. All right, so because it's sine, it's axis, high, axis, low, axis. All right, so that is one sine curve. All right, the next one, your amplitude is 5 with a reflection. B value here is 1, so your period is 2 pi, which then makes your interval pi over 2, and you're moving pi over 3 to the right, and you're moving your axis up 2. Okay, so I'm going to do my axis first. Here at 2. All right, now my amplitude is 5, so I'm going to go all the way up to 7. And then I'm going to go all the way down to -3. So, okay. Right pi over 3, but my interval is pi over 2. Okay, so let's do that. So we'll do right pi over 3, which is here. Okay, and then you're going to go up pi over 2. So pi over 3 plus pi over 2 is 2 pi over 6 plus 3 pi over 6. All right, so the next one would be 5 pi over 6. And then the next one after that is going to be 8 pi over 6, which simplifies to be 4 pi over 3. And then axis, low, axis. I need 2 more. So 8 pi over 6 plus 3 pi over 6 is 11 pi over 6. And then 3 more after that is going to be 14 pi over 6, which is 7 pi over 3. Okay, so doing sine, right? So axis, then the reflection is low. Axis, high, axis. Okay, 78. So you got -2 cosine, take out the 2. X plus pi over 2 divided by 2 is pi over 4. So A is 2 with the reflection. B is 2. So that's the period is pi, which is your interval, is then pi over 4. And then C is negative pi over 4, which is left. And then your axis is still at 0. Okay, so we're going to move left pi over 4 and then go up by pi over 4. So you got 0, pi over 4, pi over 2, and then 3 pi over 4. All right, so that should be one cycle. And then what else? So we're doing cosine now. So my amplitude is 2. So I'm going to go up to 2, down to -2. All right, so your first value is a low point. So that's low, axis, high, axis, low. All right, so 79, you got 3 cosine, take out a 4, x minus 2 pi divided by 4 is pi over 2, minus 1. So amplitude is 3, b is 4, period is pi over 2, interval pi over 8, c is pi over 2, so that's to the right, and then d is -1. All right, so d is -1. So amplitude is 3, so I'm going to go up to 2 and down to -4. We're going to move it right pi over 2. All right, and then I'm going to go up by pi over 8. So pi over 2 plus pi over 8 is 4 pi over 8 plus pi over 8. So, what is that? So we got 5 pi over 8. The next one is 6 pi over 8, which is 3 pi over 4. 7 pi over 8. And then 8 pi over 8, which is pi. All right, so it's cosine, so you're going to start at a high point, so that's going to be here at 2, axis, low, axis, high, and then you just draw your curve from that. All right. Okay, and then the last two here are tangent. All right, so we have 15 tangent times 2 parentheses x minus pi over 2 plus 1. Remember, amplitude is not really that important here. The big thing is the period. So the period here is pi over 2, right? And we're going to move the graph right pi over 2 and up 1. Okay, so I'm going to put my values first, right? So typically I would start at 0, 0, but I want to move that right pi over 2 and up 1. All right, and then I'm actually gonna do more than one cycle because I think it's easier if I do more than one. So 1 period away would put me at pi, and then 1 period away here is gonna put me at 0. Okay. So in between 0 and pi over 2 is pi over 4. In between pi over 2 and pi is 3 pi over 4. And then 5 pi over 4. And then negative pi over 4. All right, so that's 1, 2. I didn't do a very good job of spacing, but that's all right. All right, and then you got your graph for a tangent there. And then the last one here, our period is going to be pi over 3, and we're going to move the graph up 2. All right, and we also have a reflection over the x-axis. All right, so we move it up 2. So 1 period away would be pi over 3, and then negative pi over 3. And then asymptotes in between would be pi over 6 and pi over 2. And then negative pi over 6 and negative pi over 2. And then you just draw your curve. Now, because of the negative, right, we're going to start high and finish low. So start high and finish low. All right, so those are your graphs. Okay, and then the last one for chapter 4 is a calculator problem. All right, so I'm going to get that out. All right, and then, all right, so it says the London Eye is a giant Ferris wheel in London, obviously. The diameter of the wheel is 394 feet. As it makes one rotation every 30 minutes, its riders reach a maximum height of 443 feet. As a person gets on the constantly rotating ride, he starts his stopwatch. Okay, so sketch a graph for the rider's height above the ground in feet as a function of time in minutes since the rider started his stopwatch. Okay. So, I'm going to draw our graph here. So this is going to be time in minutes. And then this is going to be height in feet, right? Now, it tells me that the diameter is 394 feet. All right, so that tells me that the radius of the wheel is going to be 197 feet, right? So that's going to be your amplitude, right? So the center of the wheel, right, is 197 feet up and 197 feet down. So that is your amplitude, right? Now it says that the maximum height is 443 feet above the ground, right? So the lowest the lowest height that you're above the ground, right, is going to take your highest minus what it takes, or the diameter of the wheel, right, which is going to be 49 feet. All right, now why would I want to figure that out? Well, that's going to help me figure out where my axis goes. Okay, so if I know that my highest is 443 and my lowest is 49, what I can do is add my amplitude to one of those, and that's going to give me my axis. So that's going to be 246 feet is my axis. Okay, and then the last piece says one rotation every 30 minutes. So your period is 30 minutes long. All right, now he's getting on, right? Now it makes most sense to get on at the bottom, right? So the lowest would be 49, highest would be 443, and the middle of that we said was 246. Now, if it takes 30 minutes to do one rotation, right? If I do 30 divided by 4, right, that's going to give me 7.5. So that's just going to help me label my x-axis. So 7.5, 15, 22.5, 30. All right, so it makes most sense if he gets on at the bottom, right? So low axis, high axis, and low again. So that is one cycle for your Ferris wheel. Now it says, assuming that it's sinusoidal, write a particular equation in terms of sine and cosine. Okay, so if I'm going to start at the bottom here, set this 49, that's a cosine point, right? So we're going to say h of t is, now we said the amplitude was 197, so it starts at the bottom, so it's negative 197. Cosine, now we said the period was 30 minutes, right? So that makes the b term pi over 15. T. And then my axis there is at 246. So that's one equation, and then your sine equation could be 197 sine pi over 15 times t minus 7.5 plus 246. Okay, so what I would do is I would put one of these into your calculator. All right, that's what I'm going to do. So negative 197. Make sure your calculator is in radians. If not, you're going to get something that's you shouldn't. Pi over 15 x plus 246. I'm going to get rid of this. Now when I go to my window, I'm going to make it exactly what I have here on my paper, right? I'm going to go from 0 to 30, and then I'm going to go from 0 to about 450. Which gives me my nice curve. So it says, how high above the ground is the rider 24.3 minutes into the ride? At this time, is the rider going up or is it going down? Okay, so if you look at your graph, 24.3 would be about here, right? So obviously, he's going to be going down. So we're going to do trace 24.3. And that says 173.479 feet. So h of 24.3 is 173.479 feet. And the rider is going down. At what time in minutes is the rider 400 feet above the ground coming down for the second time? Okay, so 400 feet above the ground coming down for the second time. So based off of the graph that we already drew, 400 feet for the first time is going to be, say, roughly about here, right? So we want to know when's that going to occur the second time. So if I go back to my graph, and I'm going to change my window now. I don't want one period. Now I want two periods. So 0 to 60. And then I want to know when does it hit 400 for the second time. So y2 should be 400. You're going to graph that. So it's got 2 cycles and then 400 for the second time, which is right there. So second calc 5. So I want to get it close. And I'm going to hit enter 3 times, which is 48.215. So h of t equals 400. So t would be 48.215 minutes. And that is your answer. Alright guys, so that is chapter 4.